Welcome. We are looking now at how to interpret or analyze the graph of a function. So let's take a look at the different parts of things. In fact, we are going to specifically, with each function, decide if it's linear or nonlinear, what the y-intercept is, the x-intercept, decide if it has symmetry. On the second page, we're going to continue it with other things, where it is positive, where it is negative, where it increases, where it decreases, what the relative maximum is and what the relative minimum is, and the end behavior. And we're going to use a form to do it. There are sample graphs, but then we're going to have a graph and we're going to use these forms, this kind of a form to do it. So let's come back up to the start of it. So here, the first part of this is to interpret intercepts and symmetry. I'm going to come right down here to look at this graph. We have an upside down parabola which models the Gateway Arch, which is an American landmark in St. Louis, Missouri, where it's an arch that goes over the Mississippi River, and you can actually walk on it up to the top and through it, I believe. I've never been there, so I'm not sure how it all works. But someday this would be interesting to go up to and see. Well, we are going to determine these things from it. First, linear or nonlinear. And this one, since the graph's a curve and not a line, the graph is nonlinear. If it was a straight line like the one above here, this one we would call linear. And so this one is nonlinear. This is one of the easiest things that you can do in analyzing a graph, is first stating if it's linear or nonlinear. The y-intercept. The y-intercept is the place where it hits the y-axis. And they are saying here that it intersects the y-axis at approximately this point. Well, you have to do two things here. One of them is to give the actual point at about that, but you also have to explain it. So the y-intercept would be at 630. It's the y value is the y-intercept. But you have to explain it. This means that the height of the arch is 630 feet at the center point. Or an easier way to say it is simply if you ask what the y-intercept means, it means the height or the highest point get it so it writes correctly. That's easier to say. The height of the arch is 630. If you didn't have this sentence here, or know the exact point, you would have to estimate it. So I would have estimated at about 640, which is where this line is here. So it looks like it's just below that. So this is the explanation of the interpretation of what the y-intercept is. The x-intercept. The x-intercept will be the same idea, but for the x-intercept, it's the 2 points where it hits the x-axis for this one. So those 2 points are both 320 feet away from the center. So one way to say this is that this means the object touches the ground to the left and right of the center point. And now that brings up the idea that you can say something in different ways. So when I'm underlining in green, and I think I'll take that away on these and just circle it. What I'm underlining in green is the explanation about these points, or specifically about the actual x-intercepts. There's one and there's two, the x values of the x-intercepts. So it's where the object touches the ground. Okay, 320 feet away from the center on both sides. And that's what you want. If you want a sentence or phrase that explains That won't work there. That explains the y-intercept or the x-intercept. Now, symmetry is when you have the right half is the mirror image of the left half in the y-axis. Okay, that's an important part of the symmetry part. So in this case, if you were to draw a line right down the middle of it, the two sides are mirror images, so this one does have symmetry. Okay. So that's that simple, but it does. When you look down at the next couple, most of the real functions about modeling something don't usually have exact symmetry like that. So none of these have symmetry. We do have a linear equation, a linear function there. These two are not linear, but they still will identify the different things here. We're not going to go through those individually right now. We're going to do it with our own. But these are the four things from this page to make sure that you know to be able to say if it has these or the function has those characteristics of what they mean. Let's take a look now on this next page. And here, this one is titled about interpreting extrema and end behavior. Extrema are like the ups and downs of it. Well, and there's more to it. So the parts that I put in yellow here, we're going to look at where it's positive. Now, here is the thing about this, where it's positive, where it's negative, where it's increasing and decreasing. Positive, well, if you have a graph like this is where the y values are all positive. And this is where all the y values are negative. So negative, positive. Let's make that blue. So anything that's above the x-axis, it's above the x-axis, it's positive. If it's below the x-axis, it's negative. So when we look at this graph here, it is the entire graph is actually above the x-axis. But the way that we state it is we state from where it begins, which is 0, to where the graph, to as far as the graph shows us, which is 42. So it's from there to there. Okay, so we're x values between 0 and 42. Negative, nowhere. So no part of the domain or nowhere. And when we get to others, we'll say none. Let me write that a little bit better. So increasing. Now, increasing is going to be similar, but not the same as positive and negative. Increasing is where is it going up? Well, if we're traveling on this, we're going up a little bit, and then we're going up a lot more, and we're going way up fast, and then we're going up. We're still going up, but we're going up very slowly. So it's going along like that. So that means it's increasing for 0 to 42. And that's why we put increasing from 0 to 42. The domain, the decreasing, nowhere. No parts of the domain or nowhere. Nowhere is good enough for this. Okay. And if you had to interpret it, think about what this means to interpret it. Okay, so the number, well, this one, the whole point of this is to say another disease that is spread partly around the world. And over the course of about 6 weeks, it went up to about 11,000 or so cases. Very different from our experience a few years ago with COVID, where it was millions of cases around the whole world and went up fast. Not even close, though, to what happened with the Spanish flu right around the time of the end of World War I in 1917, 1918, 1919, where like over 50 million people around the world died. That one spread fast, and so it was very much like this kind of a spread, but these numbers would have been up in millions, not thousands. Anyway, this shows in this case, let's come back to increasing. The interpretation of the increasing is that the number, think about what it is. It's simply putting in words what it actually means. The numbers go from 0 to 42, but it means that the number of the reported cases of this disease, H1N1, increased each day from the first day of the outbreak, I would say, to the up to at least the 42nd day or something like that. But this is good enough. Go back to the others like positive and negative, we would say it's always positive because the interpretation that you have 0 to 42 is it's not possible to have a negative number of cases. You can't go below 0 and have, like, instead of having people with the disease or no one with the disease, you can't go to negative people with the disease. So it makes sense that the explanation for positive would be just that there were people who had the disease, so there's always a positive amount. Okay, now come down to relative maximum. So the relative maximum is where x is 42. That means it's the highest place that the graph goes up to. Some people would say, well, it looks like it's starting to even out, but we can't tell that. We can only see that it just went up to that. So that's the maximum number. The relative minimum number would be 0, the lowest one. Right? And in this case, it's where it starts. So the extrema indicate, or the relative maximum shows that at day 42, it's reached the peak number of cases, although there is no data after that. At least according to the graph, it's the highest amount of data in the first 42 days. And the relative minimum being 0 means that for the 0th day, or before the disease even was reported, there were no cases at that time, and that's the lowest amount. So, like, common sense, it would make sense about that. Okay, now let's look about what end behavior is. In this case, end behavior is just what happens here at the end. What's it doing? Well, as x increases, y appears to be going up and approaching about 11,000. So here's a simple way to say as x increases, y appears to go up. As x decreases, y decreases. So, as the x goes up this way, the y's go up. We're going up the y's. If we were going backwards, then what would happen is, as we're going from 42 down, the y value that's attached to each point is going down also. Okay, so going one way, it's as the x increases, or as x increases, y increases. Okay? And then going the other direction, as x decreases, y decreases. I'll use it down, I don't want to mean decreases. So that's what end behavior stands for. Let's take a look at this follow-on page. I'm going to put a little graph on here. We're going to look at what and analyze what it is. So follow along as I make this little graph. I'm going to put 5 up here. I think that's where far I want to get to. That means 4 would be about here, 3 would be about here, and 2 and 1. And this way I'm going to go 5, 10, 15, 20, 25, 30. Now, I'm going to put the title as Average Gas Prices. A study of average gas prices. Now let's label the axes. The y-axis is price per gallon. And the x-axis is the years since 1989. That means that the beginning here at 0 is 1989. 5 years later, 1994. And 5 more years later, this was 1999. And then we're at 2004, 2009, 2014, and 2019. So the prices shown here are over those 30 years, starting from 1989. So the average gas prices is one study that actually shows Some areas or parts of the country. It's not the entire thing. I don't remember exactly where this is based on, but it will make a graph that helps us to learn how to interpret and analyze the parts of it and recognize what they are. We're going to graph the following points on here: 0 and 0.9, 4 and 1.7, 9 and 1, 17 and 2.1. And I think we'll go farther up from that. And no, I think that'll be a good amount there for it. Okay, so let's go with first where 0 and 0.9 is. That would be about here. So we're estimating a little less than 1 is for 0.9, because these are my x's and y. And then at 4, which is a little less than 5, 1.7 would be a little less than 2. So it looks like we can put a point about here. Of course, these are approximately, but about as close as we can reasonably put them. Now, then the next one is 9 and 1. So 9 is a little less than 10. And let's estimate this would be about where 1 is. And then at 17 years, it's at about 2.1. Okay, so 17 is about here, and it's a little more than 2. Now we're going to play connect the dots, but things like this are not straight lines. This is going to be a curve type thing. So I'm going to curve it around the circles and use them to go up to the next one. Dots, and then this, if it's continuing, is going to be going like this. All right, so this is our graph, this blue line. What we're going to do now is analyze the different parts of it using the things from the first couple of pages with the examples and the explanations there. All right, so x-intercepts. The x-intercepts are the places where we're along the it hits the x-axis. It doesn't look like there are any. There are none. All right, so that means something. What's that? To interpret it, if there's none, that means that since the price per gallon is positive here and the price is negative here, that means the price never goes below 0, which really makes sense. It's not like gas stations are going to pay you to come to the gas station or give it to you for free. So we'll say the price of gas never went below 0. You could be even more precise, if whatever went to 0 or below, but this is good enough. The y-intercept, although I still like that, but we'll leave it for now. The y-intercept is the place where it's hitting the y-axis, and that's at the 0.9. So the point is 0 and 0.9, but the y-intercept is the y itself, so y is equal to 0.9. Now, what does this mean? What actually is the y-intercept in this kind of situation? Well, in this case, it has to do with the price per gallon, and it's saying that at the beginning year, or at the beginning of the graph, or at the beginning of the study, the price was 90 cents. At the beginning of this study, the price of gas was 90 cents. Very, very low. I knew it was low in the past, but I don't think it was that low then. I'd have to check these numbers out myself, but we're going to follow this now because it's analyzing what the graph tells us that is the point of this lesson. So notice that these two things go together, the x and y intercepts. Of course, they're opposites of each other in a way, but it's analyzing them. The category of intercepts is the first two things. Now we're going to look at the category of positive, and negative. Okay, and that means when this is the y-axis part, these are positive numbers, and down below it would be when it's negative. So where on the graph, so here on the graph line, in what areas, according to the x-axis, as you move along the x-axis, where is it positive and where is it negative? Well, right now, starting from 0 and moving along to the x-axis, all these amounts all along here are all positive. So that means it's positive in the entire graph, okay? And in particular, from x equals 0 to 30, all the way along the graph. Okay? Interpret that what it means. Well, the price is always above 0. It's in some ways really that simple. The price, let's write that more clearly. The price of gas was always above 0. So the interpretation is always some kind of simple, short phrase or sentence. Doesn't have to be really complicated. It doesn't have to be complicated at all. It just has to say what this means going from 0 to 30. And then when it's negative, it's not negative anywhere. So it's negative nowhere. And that means the price never goes below 0. And so we'll say that the price of gas was never below 0, at 0 or below actually, but then 0 is not negative or positive. The next two things go along together also. We're talking about increasing or decreasing. And this has to do, again, with the x's. So as we're moving along the x-axis, is the graph increasing or is it decreasing? Well, it's not decreasing here, it's decreasing over here. So it's increasing at that point, which means up to 4. But then it appears to be decreasing here, which is from 4 to 9. But then it appears to be decreased or increasing again all the way up for good. So let's start with the increasing part. So it's increasing from x equals 0 to 4. Okay, so along that part of the x-axis. And what does that mean? Well, when it's increasing, that means it's going up on the x-axis, so it's going up in price. So that means the price of gas was increasing as the years was increasing from year 0 to year 4. So write the word year over again better. Or we could say from 1989 to 1993. That would be those 4 years. When is it decreasing? Or where is it decreasing? It's decreasing from years 4 to 9. Okay, so from x equals 4 to 9, the price was decreasing. From 1993 to, would that be 88? 99, yes, 10, yep, that would be 1998. Okay. Now, the relative minimums and maximums also would go together because they're both relatives. It's on this graph, where is the lowest point? Even if the graph continued and went to a lower point, you would still only look at the lower point that's shown on the graph. The maximum point is the highest one on the graph, even if it might have a higher point later. Okay, so here, the lowest point, we have 2 points that look low, but we know from this and that one, 901 and 0.9, that the actual lower point is the first one. Okay, so that's our lowest point. And our highest point, now there's a relative maximum here in a way, okay? And then the overall maximum will be way up here. But we call this one a relative maximum because it goes up and then comes down in that area. Okay, so the relative minimum first at x equals 0. And that means that the price was lowest in 1993. No, 89, because it was the one that started in 1989, that first year, or actually before it even got to the first year, right when it started. Now, the relative maximum was at x equals 4, okay? And what that means is that the price went up to this amount and then started going down. So something along those lines. The price peaked temporarily at, how many dollars was that? Looks like it was $1.70. At 170 in 1993, and then went down. The end behavior part, we'll talk about it going up again, but this one's a relative maximum, meaning in an area like this, one particular area. Now, the end behavior, notice the last two are separate ones. They don't go together like the others, like each of the other pairs did. The end behavior is what's happening at the two ends. This end, we really don't need to give end behavior for because it's actually a beginning. This graph doesn't go backwards because time doesn't stop, or it doesn't turn around and go backwards. So really, we're only going to look at the end behavior as what happens as we get to the end of the graph, at the end of the x's, what's happening to the graph. Well, it looks like as the x's are going this way, which means as they are increasing in number, the y values, what's happening here is as this goes up, the y values are going up also. So the way we'd say that is as, black again, as the x values increase, the y values increase. So as, right, in shorthand, as x's go up, y's go up. Okay. Or the y values increase as the x's increase, something like that. Right. Now, this doesn't say interpret, so you don't need to interpret. It's not there. If I were to interpret, I would say that as time passes, the prices continue to rise. That does make sense. In fact, most of this is just common sense. You look at the graph and you think about, based on the title as to what it's all about, on the title, based on the direction it's going, years or speed or something else, whatever it might be, and based on the other title, the price in this case, you can tell what is happening along the graph. And that's what this whole thing is actually about. The last part, linear or nonlinear. Well, linear would be a straight line, and although one part of it might be considered straight, the whole thing is definitely not. So it's definitely a non-linear. So this can hopefully help with understanding how to look at a graph and take it apart, or the different parts of it, take it into pieces and figure out at each little part of it what they mean. Make sure you remember that if it says to interpret it, that you have to write some type of sentence or explanation about it. What does it mean the answer that you give has an actual real meaning in this situation. So you need to tell me that. If I say interpret, if I don't ask interpret, like in 9 and 10, then you don't have to write that. But all the other ones, you have to write some kind of short little phrase, sentence, a quick little expression, something showing that you understand what the actual meaning of the number is, or numbers. I hope this helps with interpreting and analyzing the graph of a function. Thank you for listening and watching.